Okay, hello everyone. Welcome to this introduction. I will be presenting one of the one of the best actually security tools when it comes to comprehensive AI attack simulation. As we all know, as AI systems become increasingly integrated into critical infrastructure like healthcare, finance, national security, transportation, and many other services and tools, there is a need for more robust security testing that is also urgent in a way, because we need to embrace new technologies and use them because they help us in the day to day. But at the same time, we need to keep secure. So that is what Kibuka does. Kibuka is supposed to help teams that are building different AI models and tools to literally quickly and test. So with the AI security crisis, we have seen several studies that have shown the alarming stats. For example, 87% of deployed AI models, they have not gone under any security testing. I do not want to mention names because it may feel like I'm attacking them, but you may know some of them. 64% approximately of organizations have experienced AI related security incidents in just 1 year, and that's a very, very big margin. And then, of course, the average cost of an AI security breach is expected to approximately 4.2 million. So we have the traditional security tools that are failing to address the unique vulnerabilities that come with AI systems, and that is where Kibuka comes in. Because what actually makes Kibuka different is that it is just not another security tool. It's the first comprehensive AI attack simulator that does not use AI, built on the foundations of MITRE and NIST AI security frameworks, to kind of find these attack vectors and vulnerabilities. So while other tools might test for one or two attack vectors, Kibuka provides a comprehensive coverage when it comes to security testing. So we have five major attacking categories within the multiple subtypes that we have in AI security. And of course, Kibuka will give you detailed quantitative risk and assessment and reports and things like that. For example, when I do the help tool here, you can see that we can see the list of attacks that we have so far, the list of available attacks that we have in Kibuka. So instead of the help, if I basically tell it to list attacks, Kibuka will basically show you that the available attack types are data poisoning, model inversion, evasion, membership interference, and model stealing. So much as we are directly mapping to industry standards and security framework, Kibuka uses a simple command line interface so that you can pass the different parameters as well. So it makes it easy for security testers to get things done. Anyway, enough with the sales jargon. Let's step into a demo. So before we step into the demo, you need to understand what we're working with. We have the repository itself, where we have a folder that has the attack results, the attacks, examples, and then the Kibuka itself, the model, and then of course the results and utils that we use. So if we need to look at our different test models, that will be in examples. We have these two. One is a Pico file actually, and we shall use this for demonstration purposes in our environment so that we could point Kibuka. And then of course in these examples you can point Kibuka to production models in your companies or in your startups or your personal things. So Kibuka works on all the major model formats, that is PyTorch, TensorFlow, Pico files, ONNX models, and many others. So it's very easy to use. So the threat landscape, let us start with demo one to understand why Kibuka is very essential. Let us try to explore by running a comprehensive security scan on one of the examples that we have here. If you look at this, first one, we can pass the different parameters, a percentile, and then a target class. And then Kibuka will launch a data poisoning attack against the best model. It will run, of course, and then successfully complete the attack. So the results are always saved to this folder. And then if we want to explore the results on this particular model, you can see the type, the status, and the technique that was used, and the model accuracy degraded. So what you're seeing here is a simulation of an attack where an adversary manipulates just 15% of your training data. There. And what happens, it results into a 37.5 degradation in your model accuracy. So this type of attack could be devastating, for example, in healthcare diagnostics. It could be devastating, for example, if we're looking at autonomous vehicles, and that is one of the things, or one of the reasons as to why this tool is really helpful. Good, so let us try another attack vector, and this is going to be on model inversion. So when we run this one, model inversion, still we are running on our local models for testing. We pass a few parameters as always. We want the gradient and then target class, and then number of iterations to be 800. Of course, Kibuka runs that on that model. And then, of course, what we want to see now is the results, because the results have been pasted. So cat attack results. That's the reason as to why I was copying and pasting, so we don't have to waste time on my typing. So this attack has reconstructed a private training data with 51% fidelity. Imagine if this was patient data or financial records, the privacy leakage score of 5.1 indicates a moderate to high risk. And there are just 2 or 5 attack categories that Kibuka can simulate. Each one of them provides a detailed metrics that go far beyond what any other tool can market. So why not do another demo on quantitative security metrics, so that we see what truly sets Kibuka apart from its other abilities, so that because we want quantitative security metrics that can translate into technical vulnerabilities. And then later, these technical vulnerabilities, we can convert them into business risks. Okay, so we shall run Kibuka on our sample models again. I passed this because of time, but in the documentation you have the different params and what you can deal with them. So of course, on this one we did run on the best model, and of course then we have the results. And now let us look at the different metrics. So this is interesting. It has caused a misclassification in 95% of the samples. That is 95% misclassification rate. And let us look at this size as well of 15%. That is 1.5 difficulty in detection, and then also a structure similarity of 0.93. That means that adversarial examples look at, they are legitimate. The examples are showing you what would literally happen in production. So these aren't just technical details, they are critical business insights that we can basically, for example, use in a fraud detection system. That would mean attackers would bypass your AI with a 95% success rate using changes that are nearly impossible to detect. Should we look at another example? Probably, because we have different types of attacks. So we can look at model stealing as an example as well. And the model stealing, we are still using the best model example. Of course, it has run, it is successful, and now we need to see what happens with the results. So, model stealing, basically, when we are talking about the business impact, it is a very good eye-opener here. Because we are looking at the model and what has been returned, and you can see intellectual property risk at 10.4 out of 10. Imagine. Competitive advantage loss, 5.2. Monetization impact, 4.2 out of 4. So this means that a competitor could effectively steal your AI model functionality with just 15. How many seconds did we take? Anyway, with 15,000 queries. And that means that your investment in research and development is lost, because a competitor can basically only run 15,000 queries, and then they have a copy of all the research that you have done. I think we have had similar stories of a certain company claiming that the other company took some of its models and things like that. So if they had used Kibuka, then would have been a different story. Let us try to see a different demo, and this demo is on customization and flexibility. So Kibuka's power comes from its flexibility. You can customize attack parameters and simulate different threat scenarios. And now this one, we run on membership inference, still on the best model. And then the attack type, we want to look at confidence thresholding with a threshold of 0.85. And basically when Kibuka runs, we need to see the results. So by adjusting the threshold parameter, it will help you to test the different threat actor profiles and simulate attacks of varying certification, and also assess the impact on the different security controls that you have. And these parameters, when you pass them in a JSON object, the interference makes it easy to integrate it into your CI/CD pipelines or even in your security automation workflows. So the main thing that you're supposed to, in this example that we are focusing on, are the different parameters and the possibility of running this in your integration, in your CD pipelines and things like that. So for demo 4, we want to move from insights to action and see what truly separates Kibuka from other tools, that it doesn't just identify problems. It basically helps you solve them, so that you can identify the different pinpoints, exactly where your model is vulnerable, and map them directly to the different techniques that attackers may use, and also the timestamps to allow you to track your security posture over time. So 51 reconstruction in the previous test that we did, you saw that it is possible. You can run 7 out of 14 features are covered. There's privacy leakage, where in which report was that actually? So it is a lot of things that you can look. Data exposure level, overall score on privacy risk, because we need to manage and merge things differently. So that means that we need to implement the different privacy techniques to focus on privacy, rather than just applying blanket protection that may degrade your model performance unnecessarily. And I have seen many organizations actually doing that, just for the sake of them saying we've applied this cybersecurity control, but they're applying it in the wrong place and the wrong time. So we have seen, and you can explore Kibuka further. It provides that unprecedented visibility into AI security vulnerabilities with actionable insights and metrics that matter both to the technical teams and also to the business leaders. So in today's landscape where AI is increasing and being part and parcel of our day-to-day processes and work, it can become a liability. So you can afford not to know your AI system security posture. Else, Kibuka can help you in that way. So to get started, all you need is to clone Kibuka and run it on your terminal. So I think This script will help very many organizations. It's open source. Uh, and with a detailed metrics and alignment with industry frameworks, it will build credibility um, in every solution that is being built.